Yo, I've been lurking a bit, but could you explain the idea of the project is? What is the end goal? Yeah. So, the end goal is to have a barcode scanner that works on my phone, that works on like a variety of images, right? So we have some examples here of like some kind of fucked up barcodes that I just like took photos of in my house, right? So there's stuff like this where, the thing is like very occluded because the like occluded's the wrong word, but like fucked up because the paint is like worn off a little bit. There's stuff like this where the bars aren't really straight and there's like perspective warping going on. There's stuff like this where there's mirrors for the bars, right, on like an aluminum can. There's stuff like this where the bag is like really crinkly and like has, stuff on top. And there's stuff like this where it's blurry and it's like kind of hard to draw lines around the exact like area that you would consider the bars to be, right? And so this is all like doable. This is all solvable with like normal non-ML methods. But the neural network way is kind of more fun. And so the end goal is to get something that like kind of works in all these cases. So we're kind of starting right now with like kind of like fake data that we're generating on the fly. Just to like get a feel for like network architecture to see like how it works and make sure that like our training framework is all set up correctly because we're kind of hand rolling everything. And then eventually we'll probably figure out how to merge in some real data. That's kind of like the high level goal. Right, then eventually we like export this thing that we trained that can do this thing, and we like build an application around it. We like export it to WebAssembly, run it in the browser, that type of shit. Okay. So yeah, our current state is that like after this thing like works okay in terms of like barcode isolation, okay enough that I want to kind of move on to the next thing. So one is that like if I want to train this thing for like 10-20 minutes, probably longer with like a more complex network, we don't want to have to like do that every time we do anything. So today's mainstream goal is going to be like model checkpointing to like basically make it so that as we train, we write down the parameters that we're tuning, and then like we can like reload them later and resume training probably as well. I'm seeing some cases where like our loss curves kind of like look like this. They get like better and better and better and better and better, and then they hit some point where they just like fucking like explode and like go like off the fucking chart. Like if this is like 10, it goes to like 5,000 up here, right? It's like crazy. And so you can probably make an assumption here that as we are like parameterizing things, we are approaching some like good value, and eventually like say it's like get really close to zero, but don't actually become zero because then you'll divide by zero somewhere, like just like as an example. That's not like actually what will happen, but you could imagine something like that. I believe there's like something like that where we're like continuously approaching some good value, and then we like hit some degenerate case and it like explodes. And if this happens after like this is like 2 hours where I'm seeing this sometimes during like my offline experiments, right? And so what we really want to be able to do is like go here and like start training from here and try fixing it, right? So that's kind of like the mainstream goal. If we assume that we're getting to the point where, okay, that's a bad example to hover on, but if we assume that we're getting to the point where we're getting like good enough bounding boxes, which I think we are. I was like looking at some of the outputs after like 20 minutes of training this morning, and it looked like pretty decent, like better than this, right? The next steps would probably be trying to stitch together like extraction of this barcode and training of actual trying to scan. So what's the problem we're trying to solve, right? The problem we're trying to solve is with scanning the barcode, assuming you had a strip of black and white is like very easy to do in software, right? We don't need like a neural network to spit out the number for us, but getting a network that can like take, this and turn this into like a concrete, strong, dark, white, dark, white, dark, dark, white, white, right? Like having something that does that would be pretty good. And so I think what I want to see is I want to start doing some experiments with our like shitty fake data, right? Our shitty fake perfect data. Just to see like if how well we can start spitting that stuff out. And then what we can do is like once we have something that like works okay for that, then we can start like stitching together dude, my brain, it's melting. like the extraction part and that part, as well as starting to like fuck up our data, trying to mix in some real data. There's all sorts of things that we can do there. But I want to start by, do you have any benchmarks yet? Found barcodes per second? No, I'm not really worried about it because I'm assuming that we can get down to fast enough, but I could be wrong there. I don't really want to do the benchmarks until like we write the CPU side code to do the, like right now we have everything in OpenCL land. Our like final answer here is going to be something like hand rolled that runs in WebAssembly. And so I don't really want to do benchmarking until we're there because I think that like how we implement that is going to kind of affect the benchmarks. So I'm not really too worried about it. But yeah, okay. So for happy hour, let's set up that experiment. I think that should be pretty easy. And then we'll think about if there's anything else, any other experiments that I might want to run today, and maybe do some reading to start thinking about next steps. But let's start with just like, let's say, we'll say 2025 0909 experiments. We'll make a directory for this thing. And we will start with our default config. But this is not where we're going to end up. Okay. So I guess we will call this experiment is try scan code. Easy. And in here, when we try to scan the code, the idea right now is that we isolate this thing in low resolution, and then we pull it up to high resolution such that we have several pixels per bar, probably at least, right? So, how many modules wide is a UPCA barcode again? Will you introduce version revision? Like if you start experimenting with different hyperparams, you might want to start from scratch for each and not load existing checkpoints. I think we'll make it so that we manually have to force a checkpoint to load instead of, like, we'll do it the other way around. Right, so I think that we're going to try to get it to the point where our network, our like application can run a variety of things. And then we will just like configure the run to pick the things that we want to do, if that makes sense. Okay, so each of these bars, or each value in this thing, is 3, 4, 5, 6, 7 modules wide. A complete UPC-A is 95 modules wide. So if we want something that is likely to scan successfully, I would think that we want like many pixels per bar. Hand wavy, right? Like maybe 4 or 5, right? So if this is 95 modules wide, then we can just like multiply 95 by 5. 475. Then like try to like get that to a power of 2. Or like something that is composed of powers of 2, maybe. We'd have like 512. That's like reasonably close to 475. But like everything yeah, fine. Yeah, that's fine. Let's do that. So we start with something that's like 512. Our batch size surely is going to have to be like way smaller with such large images. Like if we're going from 256 times 3/4 at 64. So how many pixels are we processing at 512? More. This is like over double in each direction. So like over 4 times. So 64 over 4 is what? 1 carry the 2, 16. So going on to like 10 here is probably relatively safe. I don't know what like our network is going to look like yet, so let's just kind of like skip that. But we can start looking at fucking up the image, like the data generation parameters in some way, right? So what's our assumption? Our assumption is we are going to extract this barcode based off of the bounding box that we calculated from like the first stage of this thing. I think that there might be some way to like make this all be one thing together, but we'll think about it in stages for now. So you have like bounding box extraction. There's going to be like some error in that thing, right? But like in the ideal case, we have this thing like centered completely. we have this thing taking up 100% of the width of the image, right? And we have this thing taking up 100% of the height of the image. Easy. Right? This is kind of like the ideal case. Then the rest of this, maybe this blur is gonna have to get stronger, but whatever. Let's start by loading that. Sorry, it doesn't load Python. It loads the JSON that the Python outputs. Okay. Rotation ranges here. Why? So we need to put rotation range as like a parameter of this. It's kind of hard coded right now. We need to fix that. So somewhere we have rotation range is just like hard coded. And so we just change this to min rot max rot, and this comes from somewhere. We'll put these maybe by the scale parameters, min rot max rot, and so then this stuff needs to be part of, I think that's fine. Now just like in barcode gen, we need to pass those in. So it was after scale parameters. So hold on. Here. So we instance random parameters, and after the scale stuff, we have min rot max rot, and these come from min rot max rot, and then here we have rot range here. Oopsies, rot range here. Oh, let's go. We're in sturdy hell today. It's actually fine. I'm pretty sure. I think this is like relatively straightforward. So now our default config needs to have a rotation range in here. So before, like the default thing was negative pi over 2 to math pi over 2. And then we want to change this in our oopsies, this is the wrong one. What was our 2025 experiment? What do we call this? 2025, here we go. We want a rotation range of something like relatively small, right? So let's start this with the 0 to 0 for now. And just kind of see if this does what we expect. Okay, nice. So ripping through different seeds, we see this thing kind of work the way we expect. Probably this padding on the left and right should be parameterized as well. But this is pretty good. Okay. So if we start with this, the ideal case, we should be able to easily predict the right answer, right? Because the bars are always in the exact same spot and they're always in the exact same orientation. They're always like relatively good colors. So if we start here and try to train something, just to prove that we have the data set up just now, we can kind of like adjust the data parameters after. How did you repeat the replace text action just now? Is that some built-in NVim thing? I use dot a lot. So in Vim, if you do anything and then hit the period button in normal mode, it will just repeat the last thing you did. So I use that a lot for like indentation. I use it a lot for deleting. I don't know if that's what I did just now. I don't really think about it anymore. Things just kind of happen. It might have been like change in word as well. I do that a lot too. It's like what was I doing here? Yeah, I think I did like change till comma 0 and then change till square bracket 0. I think I actually just typed it out both times here. I don't think it was like a repeat thing. But I think I just typed it fast enough that it didn't matter. Okay. So we need to make it so that we have like configurations that allow us to change the targets, right? Because I think that we're still going to be doing some bounding box tests. But we might also be doing some like bar scanning tests. And so I think somewhere we should put like our loss target somewhere, like in the config. Yeah, so how's that gonna look? We're gonna have like in our training loop, we generate training input and we use this, we have like expected here as our target. So here, we just need to change this to look at like this, the bars, right? Which I think we call sample, but I think we have that data already. Because I think the first thing that we do is we create a sample buffer that we pass into the image generator, make sample buff. So I think this sample buff is like exactly what we want, actually. This guy, he calls into sample buff. He calls into like module gen kernel. Generate module patterns. Okay. So that's in generate CL, generate module patterns. What does he create? He is creating something that is, Jesus Christ, barcode num digits plus digit width plus start end width. This is num modules. Quiet zone. So he has the quiet zone as part of this, which is a little annoying. It's a little annoying. So the quiet zone is like the borders, the white borders on the side. Right, so he is including like this stuff here as part of what he's outputting here, which is not necessarily what we want. But we can hack it for now, probably. Can we just visualize the sample buffer just to like confirm that? It's probably the play, right? Probably the play. So let's just take the sample buffer that we have right now. And just like quickly do like 2 CPU, you know, put them on the heap somewhere, attach stuff to this allocator, and can you look at sample buff, please? And can we just like write this to a file really quick? So this should be like, maybe just print it. It's probably good enough for now. Yo, yo, yo. Yo, yo, yo. So 1, 1, 1, 1, yeah. So we are seeing the white border here at the start and end. Then kind of like the start end code of this like dark white dark thing here, dark light dark. How long is this thing? Looks really long, but maybe I'm just like crazy. 945? Oh, because we're generating many barcodes. Right, of course. Right. If we just change... Are we using this? Hold on. How many is he deciding to generate at once? This stuff is taking it toll on me. Barcode gen init. Maybe it's when he updates. Somewhere num images is hard coded. Yeah, so we should just take this from the config. Oh, we don't pass it in here. We could though. Config batch size. All right. Missing fields. What do we call it? Oh, it's under data. My bad. My bad. My bad. Oh man. Bum, 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 bum. Okay, cool. So now we can adjust the size in config, set this to 1 temporarily. And now this says 105, which is 95 plus 10, so that's correct. Okay, okay. Cool, we understand. We understand. Wait, 95 plus 10? 95, yeah. 95 plus 10 for the quiet zone. Okay, so can we just, maybe if we just parameterize quiet zone size, that like, we need to make it so that when we export this thing, we have a way to discard the quiet zone from the training output, like from the training target. So what we gonna do? What we gonna do? I guess we just fucking make a new buffer for it. That's fine. So we can say, we can either copy it out. Can we just like, if we moved the quiet zone stuff outside, that would be easier as well. But okay, it's fine. We'll just copy it. We're getting too crazy. We'll call this bars. Modules maybe. Maybe bars. I think it's fine. And we'll literally just copy it. It's fine. So this is probably gonna be like bars is pass 1 out bars or something. Run first pass here. Is that what I want to do? Maybe it should come from here. Make sample buff makes more sense. We'll call this like no pad. Sure. No quiet. Or something. So we'll call this like sample buff here. And then we'll call this no quiet zone here. That's easier. And so now this guy has 2 outputs. Uh-huh. Okay. So this is no quiet buff is this, but he's not using num modules here. He is using calc pattern with no quiet. What is the 12 here for? Who fucking knows? Who fucking knows? And we don't need to do cast if these guys just return U32s, no? So why the fuck are we casting? And then we pass in no quiet buff here, and we return sample buff is sample buff, and no quiet buff is equal to no quiet. No quiet, my bad. Okay, something like this. And then we just make it so that we generate the modules. Module, generate module pattern. So here we have out no quiet. And so here we'll say if global ID is greater than like quiet zone width. And this is probably greater than or equal to. and this is less than the like we're generating many at once. This is barcode num modules num patterns out dims, and then out no quiet dims is barcode num modules minus barcode quiet zone width times 2, right? Probably something like this. Probably something like this, because you have quiet zone width here twice. So we say bar ID probably is gonna be the global ID over like modulo barcode num modules, right? Because each one of these is outputting one module or one bar, I guess as we call it here. And so then we check the module ID, I guess. And then we have our like pattern ID, I guess, is global ID divided by barcode num modules, which means that we have our, you know, if module ID is greater than or equal to barcode quiet zone width, and module ID is less than barcode num modules minus barcode quiet zone width, then we can like export this thing to out no quiet. But then the ID, the output ID here is like kind of fucked up, because it's not just like our global ID, it's like our global ID, like if we have, we're outputting kind of like something like this, and then our other output is kind of like the center portions of this. So we need to like subtract out, we need to be like, no quiet ID is going to be the pattern ID times. Can we do this? Let's make it define here. Define barcode no quiet num modules. And that's like this stuff, but without the quiet zone width. And then num modules here is with the quiet zone width. So it's just like barcode no quiet num modules plus 2 times quiet zone width or something. Cool. So now we have that guy here, which we can use for like barcode no quiet num modules. Nice. Plus module ID minus quiet zone width, I think. So this will make it so that if we are in like the correct range, then we like offset to 0. So if we're like position 5, this will go bring us back to 0. And if we're at position like, you know, 105 plus 5, that should bring us down to like 95 or something. It's kind of the goal. Who knows if this is right? Who knows? Who knows if this is right? But it might be. It might be. And we can check it pretty easily. Oh, this guy needs to return sample buff here. And now when we use this thing, we use this here and this here. Okay, let's take a little peeksies. So let's try to make like many of these. So can we go like 4, 0, 2 num images? Can we print from start is what is like calc pattern width no quiet 12 for some reason times image ID, and then end is start plus this again. Okay, and then we can look at this guy from start to end. Okay, something like this is what we're trying to get out here. I see why this was used as before. All right. So this is good. We see the 0, 1, 0 for the start code at the beginning and end if we do 1. So can we ask for multiple now? So let's make like four of these. And we should see that on all 4, fuck. Sorry for the streak. You don't have to apologize. What's up, what's up? Thank you for the tier 1. Much appreciated. Much appreciated. So this didn't do what I expected. Why? Num modules here? Oh, oops, this should be times num barcodes. Because you don't like meat? Oh, because you said steak last time. Oh, I see. 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. I think that this is correct. And then, like, these are different. Yeah. Okay, cool. Cool. This looks correct to me. So we should now be able to just take this and use it as a training target? Probably. So if we go to like main over here somewhere, we should be able to say, our training target is going to be, I guess it depends on what comes out of our config, right? So we need in our config to have, maybe like const train target. And here we will say bbox or what's our other option? What's our other option? It's bars. So we put train target here because it doesn't really live anywhere else right now. And then we have target, so train target, easy, and then we switch on the target. Expected is switch on target. If we see, you know, bbox, we return bars, bounding boxes. And if we see the other thing, bars, return bars. Okay, cool. Throw an expected here. And so then we're kind of chilling overall. Probably. I guess we have to be a little careful here because we now have to change our loss function, probably. So before we were using mean squared error here, but we do not want to do that anymore. We want to use like binary cross entropy loss for things that are going to be 1 or 0. So it would be nice if we could kind of get that in config as well, huh? It's almost like we need some sort of like loss pipeline, right? We need to be able to say like, because here's what we're doing is we're taking like bounding boxes and we are running them through the squared error function, and then we're also like applying multipliers to like each component to kind of weight how much each of that contributes to the final loss. That's like not necessarily what we're doing anymore. Like, so it kind of feels like a lost pipeline that kind of comes in from config is also nice in the same way that we have this like this layer pipeline. Yeah, okay. So we could say like here are some steps you can run. And you as your input will get what? Do they get both things every time? So kind of like the first thing gets expected, but then everyone further down the list would get just one thing, I think. He would just get like the previous result. Yeah, that's annoying. So it's like we would have to have something that's like initial loss, like loss function. And this would be like something like this, which is like squared error or binary cross entropy with logits. Something like this. And then I don't know what to do with this. With B-box prediction, there's no confidence, right? Can we still punch the confident wrong answers? Yeah, we need to do that eventually. We have to do that, like, because right now we only have like. Yeah. Hold on. Let's think about that. What you're kind of, I don't know if this is what you're intending on hinting at, but I think where this goes when you ask that question is that like to predict confidence, we have to calculate like rotated IOU of the predicted box and the actual box. And all of that is like kind of complex. Because like you need code to do that, and it's like, I guess depending on like the thing that we are doing, our loss is going to be very different. And so maybe what we should do for now is just like hard code how we handle different training targets. That's probably easier. And to answer your actual question, I think that what I'm going to do is I'm going to do that eventually, and also add like we need to add instances where there are no barcodes to our training data so that like it can predict confidence of whether or not there is a box at all, right? So he can predict like, do I think that there's a box, and do I think that I got the right box? Those should be two of our training targets, but we don't have that right now. Okay, so all of that to say, we have switch here, I guess, on the train target. And if it's B-box, we do whatever the fuck we were doing before. Okay. Is this in the wrong spot? Does block go here? Interesting. And then if we are bars, we'll just do something different. So we'll say, I think it's just I think it's literally just tracing executor, binary cross entropy with logits. Sure. Yeah. Sure. And then this is actually It's nicer for visualization if we run sigmoid over the output. So we like run our loss on like the second last thing, and then we just or we can just assume we can hard code the sigmoid at the end here somewhere. Not sure where. We'll figure that out. Here. If config train target is bars, we need to run sigmoid on the output before sending it over to the other side for like visualization. Maybe we don't. Fuck it. We'll just leave it the way it is for now and see what happens. Okay, now down here for like stat collection, we assume that we're in bounding box mode, which is just no longer true. So I think for now, if we are, doing bounding boxes, we do whatever the fuck we were doing before. Probably. And then this can probably still be here. And then if we are training bars, we'll just kind of sum the loss and write that shit out or something until we figure out what we want to do. Total loss plus equals v, and then we can do something like write this shit out. So try log writer print loss is this number. Okay. I mean, that's like a maybe. I'm surprised that compiles. That's actually kind of like shocking. And I wonder if it like works. So what was our thing? Try scan code. So this guy is going to need to set the like what do we name that shit in the config? Train target. So our default config needs train target of bbox. And then we, in our try scan code, need train target of bars. Okay, this shit doesn't matter anymore. We've got our parameters, and so let's just do, we can kind of do like the same thing we were doing before. We can do a few convolutions, get down to some. We probably want to make sure that we're not going too far. Sorry, I'm just trying to think of what I want to do here. Can we just do a linear layer for now? Like, fuck it. I just want to go like, this should be sufficient for what we're doing right now. Just like one linear layer that goes from like image size by image size to this. So we probably need to like reshape this thing into that shape first. What does our reshape look like? Here. Okay. So we're literally just like image size by image size input and just like predict that shit. Into 95 outputs. Because with what we have right now, that should work. Should. Maybe. All right. So what do we call this? We call this like this guy, this guy. I forgot a Y here. Okay, so he's ooming immediately on what? Make background image buff. Oh, because these guys are now, we're like resampling our background pictures into something that's higher resolution, so we use more memory on CPU side. True. And then also because we're doing that, we should be running with optimizations on, because that's going to be slow as fuck. Okay, but before we do that, let's up the training thread memory size. So we said you can use a meg before. I guess let's say 10 megs now. Fuck it. We can get a little fast and loose with it. You're allowed 10 megs. Fuck it. Invalid dims. And that's all we get? Why? What the fuck is going on here? Should we not be seeing more logs somewhere? Like, what is happening? Like, who is printing that? We're probably not checking the training thread anywhere, huh? We probably need to say, like, yo, no matter what, if this thing dies, try to shut down the main app. That's probably not happening right now. Like something like this? What is he sending? He's sending train response. Oh, he doesn't even have like a shutdown thing here. He has no way to communicate to the main thread that he's dead. Which, yeah, seems bad, huh? Seems bad. I guess we could do something else here. We could poll this guy. Is that like a thing that we have? Can we like check if this thread died? So there's like join, there's detach. Yield. Do we have option to like check if it's alive? Dude, the fucking way that this is rendered makes it really hard to tell. Here. Yeah, okay. I don't think that this is really that trivial. Okay. Let's make it so that we send a message back, I guess. I guess. Okay. So this guy, train response becomes a union enum who has a like usually he comes back and he says, yo, here is like the result of one iteration of training. Or like, here's a response to your request for some GUI data. I guess is what this normally is. Easy. And then we have like a shutdown. We're like, yo, we're fucking donezo, dude. Seems reasonable. Log error failed to notify thread death or something. Something like that. And then this guy's like this guy doesn't have a type anymore, so I guess this becomes like GUI data. What are you programming? We're working on our neural network framework. Training framework, I should say. To scan barcodes, we are adding in the ability to train something. So before we have something that does like barcode isolation, we're adding the ability to like flip the training loop into something that does barcode scanning instead, which we should probably put in the title. This kind of got out of hand. Barcode scanning with an N, maybe? Question mark? That's kind of what we're working on right this second. Okay, GUI data. So that kind of comes in here. Easy. This guy returns GUI data is equal to this, like this. Easy peasy. This guy's like, yo, the response. We probably want to switch on that thing. Switch on response. I guess it's like, we can do this. Just for brevity. Switch on response in. If it's GUI data, we just like pass that shit along, and if it's shut down, we just call return. Easy. Okay. So now when this thing dies, do we get like a fucking proper backtrace? That'd be hype. That'd be super fucking cool. Hopefully we at least like fall over. Yeah, okay, at least we close, and then maybe in release safe we don't get backtraces. So maybe we do a little this bad boy. First try, easy clap. Hell yeah. Okay, here we go. So this is coming from heal orientations. Oh, true. So this is like if config train target is a little bbox and this, then we should heal orientations. So true. 95.4 does not match 380. So here we're seeing batch size 4, 95. So that's the results. The trace expected looks wrong. What the fuck is going on there? Oh, because in barcode gen, when we output the new guy here for our training target, we made a mistake. This should be calc pattern width by num barcodes. He should be the right dimensions. All right. Cool. So now I guess the question becomes, does this start to look like this? Right, so we should start seeing 0, 1, 0s on the corners here, which are right? So the 0, 1, 0 at the start. Then we see 2 pixels of bright followed by 3 pixels of dark. 0, 1, 0, 2 pixels bright, 3 pixels dark. Yeah, so this isn't right yet. But also our loss is not that high. Or also we need to change the number of images. Let's, oopsies, other one. Let's up this batch size to like 10. Let's just kind of see how it feels. And then can we do optimizations on? The data is so simple that it should go to like 0.1 loss in like 15 seconds or something. Yeah, I think that it should like drop down very quickly. I think it is very simple. I agree. Are you generating actual numbers just random with bars? I don't know. I actually have like no fucking clue. I should know that. So let's see if he starts to approach something. We do see this loss going down, which is good. Let's give him a little bit more time. Just a little bit. We can even, while we watch this, we can call train output viz on train output log. And we can like look at the loss curve. Wowie! Look, he's going down. How exciting. How exciting. And then eventually he might give up. We also are, we can notice like some like aliasing here, which is kind of interesting too, right? But it should be okay. Okay, let's take a look. So 010111001. 010111001. Sure. Fuck it, dude. 11001. So then we have dark, light, light, dark, light, light, probably. Oh, we crashed. Sick. Seg fault somewhere. That's not good. Oh, out of memory. Oh, if we on the fucking... You might need a final filter to clean that up before we try reading it. I mean, I can kind of like read it a little bit. It's okay. We could just put it on top as well. But I don't really care that much. I don't really care. Well, yeah, what am I trying to accomplish right now? We're just trying to set up an experiment to see kind of how, like, make sure that like our training targets and stuff are okay. So I think Ooming on GPU. No, we're ooming on CPU. It's when it's probably like when we try to copy weights over to like the GUI thread from the training thread, and we pass over like a buffer where those things can live, and it's probably I'd probably just clicked something that made it so that we tried to copy something too big. And then our training thread crashed, and then our GUI thread is like referencing data from the training thread. And so if we like die in the training thread at the wrong time, then our GUI thread will seg fault because he's referencing data that isn't there anymore, and we need to fix that. But but it's probably like I clicked gradients. Yeah, it's if I go to gradients there, then we crash. We can fix that probably. Oh yeah, just because the gradient buffer is like fucking mega big, right? It's like 512. It's like 512 times 512 times 96. Times 4. So it's 100 megs of data there. So we can, which means that like this guy should be like 150, and this guy needs to allocate like at least 300 then. Ew. But I mean, it's like fine for now, whatever. Or we can just not click that button. And then we should also not crash. We should probably just not crash when we there. We should just like gracefully give up. But now this should work? No, still, okay, it's still not big enough. Okay, whatever. I don't really care that much for now. I just won't click that button. What we should do is we should just make it so that... Let's fix the seg fault thing so that we can at least get like a nice clean backtrace when that happens. And then we'll figure it out from there. So the seg fault is because I know what it is. It's like we're referencing some like text data from somewhere when we copy the names of our layers over to the output or to the like GUI thread. We just need to like copy the strings. So who is using those? Layer name update here. So this just needs to be like a... This just needs to be a dupe. Like this. Easy. And then this guy just needs to be called with that output allocator. So many if statements. Yeah, I mean, it's like partial updates of a struct. You kind of have to. Right, because like this response thing has like a lot of... Like, we have like a lot of things that we might give back to the GUI thread based off what it asked for. And so we just kind of like, you know, you have to check if you have the stuff that you want to send over. maybe if else, but it's not like if else. Also, like, who cares? Right? Like the ifs are there because we're doing conditional stuff. Okay, this thing needs to be tried probably. And then this guy who calls finish, he needs the like out allocator. I assume this thing is guaranteed to be okay here. I don't actually know that that's true, but fuck it. So that should make it so that we like gracefully crash. And hopefully we get our like proper backtrace out. We are great. We are exit zeroing now. It's just we're not getting like a nice backtrace on our error here, which is annoying. But whatever. Okay, we just won't click that for now. We just won't click that for now. Oh, I'm a dumbass. It's because we're fucking in release safe again. That's why. Okay, here we go. Yeah, so it's in the gradient stuff. Yeah, okay, makes sense. Makes sense. Okay, so what are we trying to do here? We are trying to prove to ourselves that we can train something. And so I guess we've kind of got there to the point where we know that there is a thing that we're training that can learn something. We probably want to increase the data randomness eventually, like now. But maybe I will do this in lockstep with updating the network. So this can be kind of our like baseline test where we just have like one fully connected layer and a bunch of stuff here, like very, very straightforward randomization parameters. And then as I experiment off stream, I can like bump up the randomization and then bump up the network to see kind of what fits. But overall, this is like something that works for now. So we can kind of commit that and then move on to the other thing that I want to do today. I think that's reasonable. So like what's in here? There's some, so we like added a training target. Depending on the training target, we do like different shit in a couple places. And then there's like some like thread management stuff in here. And then export of the sample buffer for bar mode. Yeah, sure. That needs some cleanup probably. But fuck it. Did we add any new files? I don't think so. Whip, bar scanning training target. So there's like bonus changes. We have thread management stuff to get better errors on training thread death. Is Zig the language you feel most comfortable with? What was the path with other languages until you discover it? I would say like, how do we say this? I like Zig a lot right now. It's like my go-to for sure. I've like worked with a lot of low-level languages. I like the idea of low-level languages a little bit. I get pissed off basically every day by slow software. And so like, I don't really buy the idea that we should be writing code without thinking about like the way the CPU runs, because like computers are really, really, really fucking fast. And so like the idea that code is slow in this world where computers are so fucking fast is like kind of annoying to me. So I like trend towards low level languages. I think that's probably a little extreme, right? I'm sure that like I could write, you know, a garbage collected language in a way that kind of makes sense, but then like most of like the ecosystems in C, and so like, you know, like all of the stuff that you do interop with the kernel is like in C. So it seems like being around that level makes sense to me. So I'm like basically in the land of like what are my options? C, C++, Rust, are kind of like the big ones. I've used them all. Zig's kind of like a nicer version of C. I really don't like C++. Rust is like fine. It has a lot of good ideas, but it's like overly restrictive and it makes prototyping kind of difficult sometimes. And so Zig's kind of where I ended up, where it's like C but nicer. You know? Simple, nice, elegant. You know, what are we trying to do in here? Bar sample, like export trail, like bar sample module buffer without quiet zone. Add config to support boxes still, box training still. It's most of it. Lots of cleanup to do, probably. Yeah, okay. Okay, so that's that. Oh, wait, hold on. We also have rotation ranges exposed as randomization config. That's about what was going on there. I see a lot of C++ dislike that lately. I mean, I've written a lot of C++. I've always been annoyed by it. Like, it's so easy to do stupid shit. C++11 really brought in, like, ideas that make a lot of sense, right? Like, the idea of, like, moves really, like, unlocks a lot of, like, API potential. But I think at this point in my career, I feel like I'm kind of against the idea of, like, destructors. Like, not against, but I think that they introduced, like, a whole bunch of, like, complexity, right? Like, the C++, like, memory model is just so easy to fuck up. It's so easy. And then people will, like, we did a video on this a while ago where I, like, just, like, wrote a simple class, like, maybe, like, a array-backed vector or something. And a bunch of the comments were like, just use stood vector. And it's like, I don't want to only use standard library types. Like, I think that I should be able to make types in a way that I don't, like, fuck them up. And it just seems like writing a type in C++ is, like, fucking hard. There's just so much you have to do with those, like, 5 constructors that are just easy to forget. And it's because of the fact that you need to support copies and moves and all of this, like, fancy shit. It's just hard. And so I think that, like, the cost of all of that is not worth the nicety of just having things do an action when they go to scope. Just fucking do the action when you go to scope. Okay. Rust handles it a little better because the language, like, handles a lot of that move copy stuff for you, but you also lose some of the control in Rust that you got from C++ and, like, how that memory is managed. And after, like, going through this, like, process of finding a good memory scheme that I like in Zig, I kind of, like, fundamentally disagree with the idea that every object should be destructed. Right? Like, when you have, like, an arena and a linear allocator, and you, like, allocate, like, a deep node tree of stuff, and you're, like, done with it, instead of, like, walking the tree and destructing everything manually and, like, destructing all of their children, you can just, like, nuke the fucking pool. And that's, like, it's like a one instruction operation. Versus, like, whatever the fuck you would have to do to, like, run the destructors. Which is, like, pretty sick. So I don't know. I think that they're, like, I get the idea, but I'm not sure that I think it's worth it anymore. Okay. What the fuck are we trying to do? What was the thing I wanted to do today? Model checkpointing, right? Model checkpointing. Model checkpointing. So sometimes we train things for, like, 2 hours. Then it goes away. When there are bugs, there are training bugs. Repro takes 2 hours. You still need to destruct things in pool if they allocate their own memory, not using the arena. Yeah, but I'm just like, just use the arena. You know? Just, like, put things in lifetimes and manage those lifetimes. Feels very nice to me. So, plan for today. We are going to save weights. Load weights. I guess that's kind of it. All right. Switch gears. Maybe what we just did ends up as a like mainstream video that ended up being like a lot more focused than I meant for it to be. But if not, happy hour VOD viewers, peace out. Catch you on the flip side. And let's jump into feature implementation of checkpointing.